Hello there, and let's start looking. We're going to keep talking about logarithms today with chapter 4, and we're going to do our first of 2 lessons from 4.3. If you have any questions from the first 2 assignments of the week and you haven't nominated those in the forms, I don't know that you have those questions, so remember that you want to do that each assignment that you get stuck on anything. So let's get ourselves ready for notes, and we're going to talk about simplifying logarithms. And we're going to have 3 important formulas here, some of which you maybe have seen before from your previous class, but we'll go over each of them. One thing I would like you to note in each of these formulas is that the base is the same. I know I have like a little font change just because sometimes computers are weird, but what I want you to notice is for all of them is that you have the same base. If you don't have the same base, we can get around that, but these rules only work easily with the same base. So for log a of x plus log a of y, that can be simplified as log a of x times y. And this idea is coming because logs are always equal to exponents, right? If I have a to the x is equal to y, that's the same as log base a of y is equal to x. So the x is the exponent is the log. And so if I have a to the x plus y as an exponent, that means that it started as a multiplication problem, which is why we're allowed to multiply inside of the log if we start with addition outside. Similarly, log x minus log y becomes x divided by y. And if we have y times log a of x, that's the same as log a of x to the y. And one thing that's I see a lot of students helpful to do is just put an arrow in there so you can remember going up and down like that. Now, these are really helpful rules because they help us simplify log problems that we couldn't do without a calculator otherwise. So here we see log base 12 of 9 plus log base 12 of 16. Well, since we are adding the 2 logs together, this can become log base 12 of 9 times 16. We can do that multiplication, and that's 144. And hopefully you would know from here, this is 2. If you want to ask yourself in exponential form, it's 12 to what power is equal to 144. It's squared. So this is one of the reasons that simplifying logs is really helpful, because we don't know what log 12 of 9 is, but we do know what log 12 of 144 is. Similarly, we can see in number 2, it's just a little bit more complicated. One thing that's really important to see here is that we have 2 subtracted terms. Those are both going to end up in the denominator. So anything that's minus will be in the denominator. A helpful way to think about this is minus log 3 of 18 plus log 3 of 50 inside of parentheses like this, which can be helpful at illustrating that they both need to end up in the denominator since they're both being subtracted like so. What we'll do here with the 2 is we'll move it up as an exponent just like we saw right there. So we end up with log 3 of 10 squared. Now from here we can do some more simplifying. This becomes log 3 of 100 minus log 3 of 18 times 50, which becomes log 3 of 100 over 900, since 18 times 50 is 900. Simplify from there, log 3 of 1/9, and now we're at the point where we can actually simplify that without the log, since we have 3 to what power is equal to 1 over 9. Well, that means we know that x is a negative, since it's a fraction, And then 3 to what power is 9 becomes the question, and it's 2. So our final answer here is negative 2. Now, as I said, all of these rules are based on the logs being the same. So, okay, what happens when they're not the same? Sometimes you're just going to have to say they can't be simplified, or you're going to have to grab a calculator. However, there are some cases where we can simplify. So here we see log base 2 of x plus log base 4 of x. This is one of those cases that has different bases, but we can simplify. And the important thing, the reason that we can, is 2 squared is equal to 4. So if they have an exponential relationship, you can simplify them. In this case, what we'll do is say, I want to change them both into the same base. So right now we have log base 2 and log base 4 of x. Since they have an exponential relationship, I'm going to just square the 2. However, you can't just square that and expect it to have exactly no effect on everything else. So to keep it equal, we also square the x. So it's sort of like, think about it almost like a fraction. If you want to change the denominator, you also have to do the same thing to the numerator, except for unlike a fraction, logs change with exponential terms, not with multiplication. So what we do from there is we can say, well, now we have log base 4 of x squared plus log 4 of x. They're added together. So this becomes log base 4 of x squared times x. Simplifies down to log base 4 of x to the third. And that would be the simplified form with the base change. So as I said, as long as they have an exponential relationship, this works. If this was 7 and this was 4, you wouldn't be able to simplify it, or you'd have to use a calculator. But here's what you can do when they are easier numbers like this by hand. If you have any questions, please be in contact. Nominate homework problems in the forum, and I look forward to hearing from you soon.